Hello everyone. Welcome to another tutorial of Signals and Systems with MATLAB. So today we are going to talk about the exponential signals, how we can make increasing or decreasing exponential signals in MATLAB. So when we generically talk about the signal related to the exponential, so the exponential signals as we can see in this figure can be seen here. So here we have in this part, in this starting part, we have an increasing exponential signal. But here in this portion, we have the decreasing exponential signal. We know that exponential signal, if it is an increasing exponential signal, it starts from the negative infinity and reaches to the maximum value of 1. Because let's discuss its equation first. So we have a equation for increasing exponential signal because time here is in positive. So when we have a positive time, it will tend to increase, because we know exponential signal with the negative power always tend to decrease. It will always reach to the value of 0. So if we place t is equal to 0 here, it will give us e raised to power 0, and e raised to power 0 is equal to 1. So it will depend upon the value of amplitude a, which is represented by a here. So if the a is equal to 1, so its value will always be try to reach at the maximum value of 1. So it will start from growing from the lower limit, and the maximum limit of the signal will be 1. So how we can practice these in MATLAB? So let's move to the MATLAB. Here I have opened the MATLAB. As you know, I always prefer to perform a basic simple step, which is clear screen, clear all, and close all. So if you do not know about what is the function of CLC, clear all and close all, you can watch my previous videos. But to make you understand a little bit about it, let me explain these as well. CLC stands for clear screen. When we run this command, it clears the existing outputs in the command window. So when we run the clear all command, it clears all the stored variables which are available in the workspace. And the close all command is used to clear the or close the all existing open MATLAB tabs. Why I prefer to do these steps? Because usually I keep on practicing MATLAB. So it is possible that you are working within MATLAB and you have stored variables in the workspace, and you are running a very long code in MATLAB. There is a possibility that your compiler will extract the values of those variables from workspace and execute your code on those bases. So to avoid this confusion, we prefer to clear our workspace. So that's why it is always recommended to start your programming in MATLAB with all of these commands: clear screen, clear all, and close all. So now let's begin on developing an increasing exponential signal. So we will be plotting these signals on a 2D plot. So on a 2D plot, we need to have an x-axis and y-axis. And on that x-axis, if we are talking about a continuous time exponential signal, on that x-axis we will need the value of time, and on the y-axis we will have the output values, which was given here. Y of t is equal to a e raised to power minus at. So here this t is our time and a is the amplitude. So let me develop this equation in MATLAB first. So to begin it with, let me initialize time. So let me suppose that the signal is ranging from minus 10 to 10. I will be using the same time limit here. In my previous video, I used it from minus 10 to positive 10. Those are basically 21 samples. First 10 samples are from minus 10 to 1, and the next 10 samples are from 1 to 10. And that very specific centered sample or the time which is 0. So collectively when we count this array, we count this row vector, these are the 21 elements present in this row vector. So minus 10 colon 1 and 10. I want to give a jump or the spacing between the I want to jump my array with this step size of 1. So basically this 1 is the that basic step size. So first of all, let me initialize its amplitude a. So I am going to write it 5. You can have any value, you can have 1, 2, 3. So when I write here a is equal to 5, it's mean that its maximum value will be near 5. It cannot cross that very specific value. At t is equal to 0, it will have the maximum value 5. So now, okay, fine. So now let me make this signal. Signal is equal to a static. For exponential, we use the command exp and small braces starts, and then we have to place this a and t. So a static time. Okay, fine. Now I have successfully made this command here. I have successfully made this equation in my compiler. So now I want to plot it. So plot time comma signal, and now I want to give it a title. So I will write it continuous time increasing exp signal. Okay, fine. To save time, I'm just writing this. For to label my x's, I will use x label. So x in x label, I will write time, and for y label, I will only write amplitude to save my time. So let me run this. Let's see what it gives us. Here, since I have saved this in another folder, so when this MATLAB editor show you this action, you have to just add it to the path. So now I have added it to the path, and now I'm waiting for my output. Okay, now it has shown us the output. Here you can see that it is giving us an increase it is giving us the increasing values. So basically the signal was in this nature, so it started rising from here. So this was due to the step size. So to make it more convenient for yourselves, let me reduce its time so we can plot maximum samples in it. Now you will see that it will give us far more better results when I run this command. So basically step size determines. Now let you here you can see that here you can see that it has more smoothness than the previous ones, because from exponential value 10 it had the 0 value because those values were very smaller. So that's why from this point it began to show us the increasing trend in it. So if I can show this more appropriately, okay, sorry, to zoom it, we have to just click here. So I am trying to zoom it out so we can see its actual graph. So that's the way you can make an increasing exponential signal. So now if you want to make this signal in discrete times, so you will write the figure command. What it will do, the figure command will open a new window for your figure, and here you will have the samples. So sample values, I am going to copy the same samples so we can compare these graphs side to side, and I will take all of these and I am going to paste it here. Since all the attributes of the signal are same, just one thing will change. For continuous time signals we use plot, and for discrete time we are going to use stem command. Now let me run this. Now you will see that here we have two windows, and in one window, figure 1, we will have a continuous time graph, and in the second window we will have a discrete time graph. So here it has a continuous trend, and in this part it has a discrete time. Okay, fine. So this is the basic agenda related to the continuous time and discrete time graphs. So if I make it more open, here you can see that since our step size was very small, so it has plotted the discrete values on all of these points. So if you decrease the step size of this figure, it will have lesser samples in it, and it will make it more better. It's your choice. You can either have it in increasing or decreasing manner. So this was the case for the increasing graph. So what if we want to make a decreasing graph here. So I will write another figure window because I want to compare at the end of this point. I want to compare all of these four graphs. So I have wrote the figure command, and now let me make a continuous time decreasing graph. Here I will write continuous time decreasing exponential signal, and now I will place a negative sign with this time. I will just make its time negative. So let's see what it gives us. You can place this negative sign here as well. It's your choice because it has the commutative property. So it doesn't matter where are you going to take it. And now let me make a discrete graph as well. So here I will simply have to write this temp command, and now discrete time decreasing exponential signal. So now I will run this command, and you will see that four figures will open. The figure 1 and figure 2 will show us the continuous time and discrete time increasing exponential signal. Meanwhile, the figure 3 and 4 will show us continuous time and discrete time decreasing exponential signal. So let me run it. It will take some time. So I have got some error here. What kind of error it is? Let me check it. So it is in the line 24, column 24. So here it has the error. So I think I have added an extra uh, smaller bracket here. So let me save it and rerun this. Let us check what if it has any error or not. So I'm okay, now it has no error in it. So let me distribute all of these commands so you can simply watch this amazing phenomena of the exponential signals, how it is very easy to make these signals in the MATLAB. So on the right side we have the discrete graphs, and the on the left side we have continuous time graphs. So you can see from here by this visualization that this is continuous time increasing signal because its value is increasing, and it will try to reach its maximum value which we gave it in our coding. And here it is the decreasing increasing graph, but it is in discrete time. So when we talk about the figure 3, it has the decreasing exponential signal trend, and it is in continuous state. And if we talk about the figure 4, it is decreasing exponential signal, but it is in discrete time. So I hope I tried to make it very simple for you so you can understand it better. I hope you would have liked my video. If you need any more tutorials like this, just leave a comment. Do not forget to subscribe and like my video. Thank you so much. See you next time.